In this video, we'll walk through how to run the ARIMA time series function using UnifyML SQL. The ARIMA time series function algorithm is executed via a UnifyML query. Here, we run the ARIMA time series using the UnifyML query. Let's dive into this simple ARIMA time series example. Before running the ARIMA time series, let's first look at the data used for the ARIMA time series. I'm using a table named monthly train data, and we'll limit the query for this example. Let's run this query. This query will execute in the backend of our UnifyML server. The output shows the monthly train data with a date column indicating each month and the corresponding sales data. Now, we need to predict future sales based on this data using the ARIMA time series. To run the ARIMA time series, start by specifying your required input table name and input date column. In this case, the forecast count is set to 10, meaning we want to predict the next 10 months of sales data. You can change the forecast count based on your needs. The target column to be predicted is the sales data, and if needed, you can change the data types of the columns using the input data types parameter. In this example, I'm changing the product date column's data type. The seasonal value is set to monthly with a period of 12, indicating that we have monthly seasonality. Other parameters for the ARIMA time series include input columns partition column, and several others like max order, d-value, max P, max D, max Q, and more. The seasonal setting can be adjusted to true if you want to include seasonal data. You can also split the data into training and test sets using the training sample size parameter, and parallelism can be set for performance optimization. Data cleaning methods are available for handling missing values or outliers. You can remove rows with null values, remove duplicates, remove outliers, or fill missing values. Data scaling options include min-max scaler, standard scaler, normalizer, and binarizer, with the ability to specify minimum and maximum values for scaling. You can use the input cache ID if the table has already been cached, and the summary option can be enabled to view a summary of the data. Once the parameters are set, run the query, and this will execute on the UnifyML server. The output will show the next 10 months of predicted sales data. Next, let's look at another example using hourly train data. I'll run a select query to see the data used for ARIMA. Let's run this query. The output of the hourly train data includes product date and corresponding temperature for each hour. Now, let's run the ARIMA time series on this hourly data. Specify the input table input date column and the target column, in this case temperature. You can also adjust the data types for the columns if needed. The summary option is set to true, meaning we'll see the data summary. After running the query, the output shows the accuracy metrics for the time series prediction, including MSE, MAE, RMSE, and R2 values. In this way, you can apply the ARIMA time series function to any of your time series datasets using UnifyML. Thank you for watching this video.